We are into the last lap of our school life, and I'm going to discuss you on some tips in nailing paper 1. In Max paper 1, we have Algebra Equation Inequalities for 25 marks. We have Patterns and Sequences again for 25 marks. Finance and Growth. Finance, growth and decay comes in 15 marks. Functions and graphs comes in 35 marks. Differential calculus 35 marks. Probability 15 marks. So we have 1, 2, 3, 4, 5, 6 topics. Question number 1 will be algebra. This will be our question number 1. Generally, patterns and sequences, question number 2, question number 3, or maybe only question number 2. Then we start from functions. Functions will be question number 4, 5, 6, or probably only 2 questions. Then will be followed by question number 7 will be finance. Then 8, 9 and 10, that includes application, will be graphs, cubic graphs, and some basics of calculus will be question number 8, 9 and 10. And then finally for 15 marks will be probability, maybe question number 11 or question number 12. Let's first see on algebra, equations and inequalities. Information sheet. First few minutes of your exam you must spend on reading the instructions and go through the questions without writing anything. And please take care of the formulas, important formulas that given in the information sheet. Most of the formulas are given in the information sheet. Please go through them. And if you have any formulas that is not in the information sheet, you can write it down before you start writing any question, attempting any question. That will help you to recollect when you start solving the problems. So my suggestion is, first go through the information sheet. Yes, you know it, but still browse through it. And if you have any other formula that, for example, it might be related to area and surface area, volume, so on, you might be requiring this. Write down that formula so that when we are at the peak of our time, then we may have chance that we may forget. So please write down at the beginning when our mind is cool. In paper 1, question 1 is algebra, equations and inequalities. We must master this particular topic. Algebra is not only required in answering question number 1, in subsequent questions as well as in paper 2, we must be very, very strong in algebra in order to solve most of the problems. Without having a strong foundation in algebra, we may not be able to solve many of them. We will struggle. It will be a challenge for us if we are not comfortable with algebra. When it comes to algebra, we have very foundation of adding and subtracting like terms. We know how to multiply binomials, trinomials, and we are also comfortable with simplifying with the expressions like this involving rationals. It actually starts from the foundation of 1 over 2 plus 3 over 2. We all know how to add these numbers with the same denominators, but when are of different denominators, then we'll have to take the LCD. So we must be very comfortable with these arithmetical operations that is extended to algebra. Now, the first question that we will come across here on question number 1 will be on solving quadratic equation. So, quadratic equation is nothing but a polynomial of degree 2. highest power of the variable is 2. So we have the standard form of a quadratic. So very careful here, we must understand the standard form. First term is the second power of x, right? And then is the x, and then is a constant. So first term is x squared, second term is x, and the last term is the constant. That's the standard form of a quadratic equation. We know three methods. We have learned three methods. Factorize means we are here in this standard quadratic, we factorize the linear factors. Then we'll know the completing the square method, which we also extend this particular concept in conics, in circles. Then we have the quadratic formula. There may be other methods, but our CAPS document is confining to these three methods, and we must be familiar with these three methods. Factorize originates from the very important understanding which I call them as a zero factor law or zero factor theory, whatever you call it. A times B is equal to 0 implies A is equal to 0 or B is equal to 0. So that is why we are factorizing, because we apply the zero factor law. What is zero factor law? When I multiply two factors, I get a 0, then either of the factors have to be 0. So here we have to be very careful here. Let me take one quick example. X squared plus 6x plus 5 is equal to 0. If I factorize 5, I look at the factors of 5, that will give me a sum of 6. Is nothing but 5 and 1. So x plus 5, x plus 1 is equal to 0. You can see here there are two factors here. So x plus 5 times x plus 1. That is similar to A times B. So here I have x plus 5 is equal to, I apply zero factor law. here. And I get x is equal to -5 or x is equal to -1. Care must be taken when the question changes to x times x minus x plus 3 is equal to 28. So x times x plus 3 is equal to 28. Don't make this is a wrong thing to write x is equal to 28, x plus 3 is equal to 28. Yes, is a wrong mathematics. So what we must do here, we must have the standard form of the quadratic equation. What we will do, we will expand x square plus 3x is equal to 28. X squared plus 3x minus 28 is equal to 0. Now I look for factors. This is negative 28. Therefore, I look for factors of 28 whose difference is 3. So I look for factors of 28 and I get 7 and 4. Therefore, this is x, and where I put 4, where I put 7, because I get a positive 3, therefore positive 7, negative 4. So when I expand, my suggestion is always when you factorize it, please expand and see whether you are getting the original equation, right? So x squared plus 7x minus 4x, right? So we have to be very, very clear here. It may take one additional minute, but that is worth, because we don't want any mistakes to be done. We want to be perfect, and therefore I get x is equal to -7 or x is equal to positive 4. Right? So that's how we saw the standard form of a quadratic equation. Next is completing the square method of solving a quadratic equation. Completing the square is based on the premise that we can solve a quadratic equation of the form x plus m the whole square is equal to n. We can solve this particular quadratic equation without actually expanding x plus m the whole square. What we can do, we can take the square root on both sides and we get x plus m is equal to plus or minus square root of n. So now any quadratic equation can be changed out to this form. That is what our purpose is in completing the square. Let me take an example here. 3x squared, and doing an example so it's easy to understand. 3x squared plus 7x minus 12 is equal to 0. So there are several steps involved. My first step is to make the coefficient of x as 1. That's my first step. So my first step is coefficient is equal to 1. Coefficient of x square is equal to 1. That's my first step. That is, I divide by 3. That is x squared plus 7 over 3x minus 4 is equal to 0. The first step. My second step is to take the coefficient of x, that is b over 3. So coefficient of x divided by 2, that is 7 over 3 divided by 2, that will give me 7 over 6. And then my step number 3, what I got in step number 6, I must square it, right? That is the square of step 2. That is what we must do here. That is 7 over 6 the whole squared, and which is equal to 49 over 36. Now step 4 is a rearranging. That's what I'm going to do here. Step 4 is a rearranging. That is x, what we got in step 2, that is x plus 7 over 6 the whole squared. Minus, I am always minus step 3, that is 49 over 36, and write minus 4 is equal to 0. So you can see what I did here. Step 2, I got 7 over 6, I wrote here as x plus. If it is plus, I'll write plus. If it is minus, I will write minus x minus. Then step 3, we got as 49 over 36. We always subtract minus of step 3, that is minus 49 over 36, and write the constant as it is. If it is minus, it is minus. If it is plus, it is plus. Now I calculated as x plus 7 over 6 the whole squared. I add this 49 over 36 plus 4, or sorry, it's minus 4, and I get as you do the calculations, use your calculator. I get as 193 over 36 minus that is, if I transpose that becomes positive, so 193 over 36. Now I apply this this method here. Is very straightforward. I take the square root on both sides, so that is why we put of this method, we use this method. That is now x plus 7 over 6 is equal to, I take the square root of both sides, 193 over 36. That is, I get it now. I can conclude my answer, which is x is equal to negative 7 over 6. Both are 1 over 33. Square root of 36, 6, so it is denominator is 36 on both sides. So x is equal to, for both terms, minus 7 minus square root of 193 divided by 6. So this is the approach that we use for completing the square method. Yet another method to solve a quadratic equation is using the formula. We know the standard form of a quadratic equation is ax squared plus bx plus c. So standard form and of the quadratic equation. Now we can solve this using the quadratic formula by using the formula x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. This formula is also given in the information sheet. So please go through the information sheet also, or you must be very thorough with this particular quadratic formula. So if the question doesn't mention of any particular method to solve the equation, we can always rely on this quadratic formula in solving a quadratic equation. The key here is to identify that this particular equation is quadratic and then use the formula, or completing the square method or factorization. There is a key thing to do is to identify that it is a quadratic equation. Right? For example, here I am doing next question. Instead of example, I will not be solving it. I am just giving an idea. 1 over x minus 2 plus x minus 1 is equal to 6 over x. So in this particular case, what we do here is we take the LCD. And what will be my LCD? That is, we multiply with every term, right? Every term with x minus 2, x minus 1. Oh, there is also x here. So I multiply every term with the LCD, and that is x times x minus 2 times x minus 1. And then we obtain an equation, and we can solve that equation. We can simplify that, and we'll get a quadratic equation. I'm going to the next equation here, x plus 2 root x minus 3. This is also a quadratic. Doesn't look at the variable is having a square here, but still it is a quadratic. There is a quadratic in root x. Therefore, I can write root x is equal to my a, my b is, so I can write is 2. So I can write minus 2 plus or minus square root of what is my b? Yeah, b is negative 2. So it is 2 squared, which is equal to 4 minus 4 times 1 times negative 3 whole divided by 2 times 1, because my a is 1. So I get minus 2 plus or minus square root of 16 divided by 2. That is minus 2 minus 4 divided by 2, or root, I'm still root x, remember, is a root x is equal to, because it is a quadratic in root x, so minus 2 plus 4 divided by 2. So this is not a possibility, because root of a number, of any real number, cannot be negative. So I remember this one here, square root of a real number, square root of any real number, square root of any real number is positive. Remember that, right? So I cannot have a negative number. The square root of any real number cannot be negative. I want to clarify one more thing here. See, when x square is equal to 6, x square is equal to, say, 36, right? X can take two values. X is equal to 6 or x is equal to negative 6. Remember that one, right? But square root of 36 can take only one value, that is 6. Understand the difference between these two, right? X square is equal to 36. I am taking the square root on both sides. In that case, I will get plus or minus 6. But when I take square root of 36, I get only one value, and that is positive 6. To get negative, I must write here negative root 36. Understand the difference. Now I will discuss on a nature of roots. As we have seen, the quadratic formula, x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. And this here, that b square minus 4ac, the inside the third, right? Inside the set is positive, then it is a real. If it is negative, that is inside the set, which we call them as discriminant. Let me use the color, which we call them as discriminant here. If the discriminant is positive, it is real. That is, which we write as, in short, we write as delta. It is nothing but b square minus 4ac. If delta is positive or 0 or positive, then the roots are real. 0 or positive, 0 or positive. If delta is equal to 0 or positive, roots are real. In other words, I am going to define what is non-real. Inside the set, right, if x is negative, then root x is non-real. If x is negative, right, then x is non-real. This is a definition of a non-real number. We also, in mathematics, we also call them as imaginary numbers, or a new branch of numbers, which we call as a complex numbers, but it's not beyond the scope of our caps. But you must understand this non-real, that is, inside the set, if it's negative, then the set is non-real. In other words, root x is non-real. X is not non-real, root x is non-real. Remember that one. Based on the values of the b square minus 4ac, we classify the roots. First one, as is, roots are real and non-real. Our first classification is real and non-real. Second classification is rational and irrational. Rational or irrational. Third classification is equal, unequal. Okay. So my first classification is real or non-real. Second is rational or irrational, and the third one is equal or unequal. So these are three classifications that we are going to discuss. This second and third classification only is applicable if the roots are real. So I am looking at the discriminant, which I write as the form delta or d. Delta is nothing but b square minus 4ac, which is inside the set of the quadratic formula. So when delta is greater than or equal to 0, roots are real. Right? If delta is less than 0, then it is non-real. That is, it is negative. So if what you observe, what you get, the calculation of b square minus 4ac, if it is negative, then it is non-real. If it is positive, it is real. When it comes to rational or irrational numbers, then it depends only for real numbers, only for the positive values of delta. Right? That is, if delta is always greater or equal to, so that means real. Now, if delta is, I think I must write the delta greater or equal to 0 for these two, right? Because it's applicable only when it is greater than or equal, when delta is, right, delta is greater than or equal to 0. So when it's rational numbers, means you look at the delta is already greater than or equal to 0. Then if the delta is a square number, right, is a square number, then it's a rational, then roots are rational. If not a square, is irrational. I will come back to this again, what is a square and what is not a square. Then equal and unequal. If delta is equal to 0, roots are equal. Right? That means when this becomes 0 here, roots are equal, because roots will be, this minus b over 2a will be my roots. And if you still compare with this as a quadratic function, then it will be parabola graph. Then again, for equal roots, that will be the turning point, and which again is the x-intercept. Okay, now let's come back to nature of roots. I will solve one or two very basic problems on nature of roots. Let's take this question here. What is the value, for what values of x? For what values of x? Yeah. For what values of k such that the equation x square plus 2x minus 4x minus 9k have equal roots? So my first step in question, for questions like this, or depending on the nature of the questions, or questions on nature of the roots, will be my step 1 will be to put the equation in standard form. I have to ensure the equation is in standard form, right? Then I will calculate, my step 2 will be to calculate the discriminant. That means I calculate a discriminant. And then I find the nature of the roots, or I find the relevant value. And then will be the step 3. Either will be to calculate the nature of roots or to calculate the value of k, depending upon the question, or to confirm whether it is real or non-real. Let's take this question now again. X square plus 2x equal to negative 4x negative 9k. My first step is standard form. That is x squared plus 2kx plus 4x plus 9k is equal to 0. I have to find this k. And there's a k here. So x squared plus 2k plus 4x plus 9k is equal to 0. So I have to find now, I have to discriminate which all my a will be equal to 1, my b is equal to 2k plus 4, and my c is equal to 9. Now I find the discriminant. My discriminant is delta, that is b square minus 4ac. That is, this is my second step, calculate the discriminant. Okay, I calculate the discriminant. That is 2k plus 4 squared minus 4 times a is 1 times 9. That means I have to solve for, I have to find the discriminant. Let's calculate. I use the FOIL method. I simplify it and I get the answer as 4k squared minus 20k plus 16. You can simplify it and you will get it simplified answer. Now look at the condition. The condition that is given, step number 3 is what? Step number 3, right? Step number 3, what it says, have equal roots. Now you make it delta is equal to 0. Look at read the question very clearly. Don't on the first step make it equal to 0. The question can be real roots. We do not know what it is. So now the question is, you have equal roots. That means I equate it to 0. First you calculate delta, then you equate it to 0. Or then you say b square minus 4ac is equal to 0 for equal roots. Or delta is equal to 0 for equal roots. Now you equate 4k squared minus 20k plus 16 is equal to 0. Follow a routine, follow a certain procedure that will help us. Now is nothing but is a quadratic in k. As you can see, you can use a quadratic formula, or you can use a factorization, you can use a complete square, any method. You can simplify it. Right? Now I would divide by 4 k square minus 5k plus, to reduce it to a similar one, that is k minus 4 k minus 1 is equal, I did factorization of the trinomial and I get k is equal to 4 or k is equal to 1. So that's how I get it, for what values of k such that the roots of the equation have equal roots. That means if I put this k is equal to 4 in this particular equation, or 1 is this particular equation, I will get equal roots. I am still in the nature of roots. Yes, the questions can also come very related to functions. F of x is equal to c for what values of c. roots are real or non-real. For what values of c, questions can come like this: for what values of c such that f of x is equal to c are real or non-real. I will discuss them when we summarize on functions, but they are also related to nature of roots, but we may not apply the discriminant formula there. That becomes more complicated. So we will avoid that. In that scenario, we have a better method of solving for questions like this: f of x is equal to c. Though it's a nature of roots, we will not apply this procedure. The procedure discussed was only of the form of the pure quadratic in question number 1. In question number 1, we will also come across questions on exponents and sets, where we apply the laws of exponents. Remember, laws of exponents can only be applied to multiplication, division, and brackets, and not for addition and subtraction. We have no laws for exponents for addition and subtraction. So very careful here. I'm just giving it. I'm quickly go through the laws of exponents. And 2 times 2 times 2 times 3, same basis. So it's 2 to the power of 5. I add the basis. Right? So here the laws is for same basis. For multiplication, add the exponents. For a laws of exponents, we ensure that we apply for the same basis. Even for division, a over, we apply for the same basis. We take the difference. This is for the multiplication, this is for the division. In fact, both of them are this one and the same law, but we see this differently, because why they are same? Because you can see, we know that 2 to the 2 square, we can also write it 2 to the power of negative 2, right? So writing in positive exponents and negative exponents. So if we write like this, a to the power of n divided by a to the power of n, I can write as reciprocal of this a to the power of n, which is, and now I apply the multiplication, that is a minus n. So in fact, both of them are the same. It originates from the fact that using the law of writing in positive exponents or negative exponents. So when we take the reciprocal, we change the sign of the exponent. That's a key thing here. So where we make mistakes here, when we take a reciprocal, right? When we take a reciprocal, change the sign of the exponent. All right. Now it is very careful. This law is very, very sensitive, where we often commit mistakes. In the question like this, 1 over 3 x to the power of negative 3. How can I write in positive exponents? Here, remember, this negative 3 is applicable only to the x. So I'm taking the reciprocal of x. I'm not taking the reciprocal of 3. Right? So 3 must remain in the denominator. I'm taking only x to the, and change the sign of the power of x. Remember, I am taking only the x, my x to the numerator. I'm taking the reciprocal only of x. 3 remains in the denominator. 3 is not the base of negative 3. The base of negative 3 is x. So we must be very careful when we apply this law here. Then we have the law that involves brackets. and that is 3 squared to the power of 3 will give me 2 times 3, which is equal to 6. So it's simply multiplying the brackets distribute. So this 3 is actually this 3 the here you see here is the base is 3 to the power of 2. That is why we multiply it out and we distribute it. And then power. One important thing I should have started from here. A to the power of 0 is 1, right? That is power of 0 to any base is 1, is unity, is equal to 1. Then we have for equal powers, for example here, so far we did equal bases. For equal powers, let me take here 3 to the power of 4 times 2 to the power of 4. Okay, here my powers are same but bases are different. So when the powers are same, I can multiply out. In fact, is a reverse law of this brackets one here. And that is 3 to the power of 2 times 4. That means when the powers are same, I multiply the bases. And same rule also applies for the division also. Now comes to the surds. Surd means writing the exponent in root form. Exponent in root form, especially for rational exponents. That is 3 to the power of 1 over 2, we write as square root of 3. 2 to the power of 4 over 5, we say fifth root of 2 to the power of 4. So here this is the surd form and this is the exponent form. In fact, we must be able to interchange between the surd form and the exponent form, and from the exponent form to the surd form. Laws are also applicable to surds also. That is, for example, root 2 times root 3. We can also put 2 times 3, which is root 6. Applying this law here for equal powers, the powers of 2 and the powers of 3. In this case, here is 1 over 2. So I just have to multiply the bases and put the power. So we have the surds in simplifying exponents. We'll also have rationalizing the denominator when it comes to surds. Rationalizing the denominator. And that is, if the question is 3 over root 5, rationalize the denominator. You can see root 5, square root of 5 is an irrational number. I have to make this root 5 into a rational number. That is the purpose here. That is, I write as 3 root 5. I multiply root 5 and root 5 denominator numerator. So I can write as, I should be 5. That's 3 root 5 over 5. That's the rational denominator. It also comes with the binomial terms on the denominator. Well, I am taking another example here. For example, that is rationalize the denominator 3 divided by 5 minus root 7. So how we do this? I call them as a conjugate. I multiply with the conjugate of the denominator. So if it is if it was plus, my conjugate would have been minus. Since this is minus, my conjugate is plus. So I multiply and divide with this conjugate. So it is 3 times 5 plus root 7, and I apply here my knowledge on expansion of this. It is a minus b times a plus b. So that will give me a square minus b square. This is 5 square minus root 7 squared. and that will give me 3 times 5 plus root 7 divided by 5 squared minus 7. The square root of square of x. Square root of x is x. Remember this law also. We can learn it as a law, but square of a square root is the original number. So I get as 3 times 5 plus root 7, and that will give me 25 minus 7 will give me how much? 18. So which I can simplify as 5 plus root 7 divided by 6. Divided by 6. It's supposed to be 6. Yes. So this is how we simplify the sets, or which we call them as a rationalize the denominator. We also have in exponents and sets, we'll also have equations that involves exponents to solve. Let's take this example. X to the power of 3 over 2 divided by 2 is equal to 4 and 1 over 2. Let's be careful, this is a mixed fraction, so if you are using a calculator, please be very careful when you punch in as a mixed fraction, not as 4 and then as a fraction 1 over 2, which is different. So try to input in your calculator as a mixed fraction. Or if you know how to change it, is 4 times 2 plus 1, which is 9, so it's 9 over 2. So my first step, I simplified it. Now I isolation of the power, that is, I have to multiply 2 on both sides, and I will get as x to the power of 3 over 2 will give me 2 times 9 over 2, and that will give me x to the power of 3 over 2 is equal to 9. Now what I'll do here is I transpose. When I transpose this power to the other side, what I'll do, to make it as a 1, on the power I multiply with the reciprocal of the exponent. So that is a rule that I apply here to solve for the base of an exponent. That is, x will become cube root of 81. So that's how I solve for the base of an exponent. And to solve for the exponent, one of them, this is to solve for the base. Now this, if the power is if the variable is the power, or if the power is a variable, then 4 to the power of x is equal to 16. Then my purpose will to have the equal bases, and then I can equate the power. That's here what I'm doing is equal bases will have equal powers. So I apply that rule here for equal bases, equal powers. Right? We'll have equal powers. That's the rule that I use here. And sometimes we will not be able to use it. We will not be able to have the equal bases, and we will not be able to find equal bases. Therefore, we'll use logarithm at that side to find the exponent, which is a variable. These are some of the simple questions that we can have. We also involves exponent that will have in quadratic. So it is exponents and quadratic. Let me try to take two set of questions that we normally come across. This is 2 to the power of 2x minus 6 times 2 to the power of x is equal to 16. It looks like an exponent question. Now to solve this, one of the methods I would suggest recommend is to have the substitution method. This is a quadratic in 2 to the power of x. As you can see, it's a quadratic in 2 to the power of x. You can see 2 to the power of x. The square of 2 to the power of x is 2 to the power of 2x. Right? So if let it be equal to k, then if I square them, then I get 2 to the power, ax should be inside the bracket, 2 to the power of x, square them, that will become 2x is equal to k square. So identification that this is a quadratic is important in this particular case. is actually a quadratic in 2 to the power of x. Now that is, I can write as k squared minus 6k minus 16 is equal to 0. Now I can solve for k. So I can solve for k by factorizing is negative factors of 16. I get 8 and 16. So it's k minus 8 and k plus 2, 8 and 2. The difference of 6. So I get k minus 8, k plus 2 is equal to 0, k is equal to 8 or k is equal to negative 2. Remember the question is to solve for x, so I have to replace now k with 2 to the power of x is equal to 8 or 2 to the power of x is equal to negative 2. So now I apply the laws of exponents here, equal bases. So I have equal bases I have, and then equal bases will have equal powers, therefore x is equal to 3 in this case. Well, the power of a positive base will never be negative, right? Will never be negative. So no solution here. So no solution on this side. So my answer is x is equal to 3 only. There's one kind of questions that we come across in this particular and that involves exponent and quadratic equation. Here I used a substitution method, or if you are very comfortable in factorizing in terms of 2 to the power of x is also good. But the key here is to understand that this is a quadratic equation in 2 to the power of x. So that is a key in this particular question, that integrates exponents and a quadratic equation. We also have a different question on exponents and exponential question that need not involve quadratic. For example, it is 2 times 3 to the power of x plus 1 plus 5 times 3 to the power of x is equal to 33. Here there is no quadratic, it's not a quadratic equation, it's an exponential equation. So what I'm going to do here is I take the common factor as 3 to the power of x. So it becomes 2 times 3 to the power of 1 plus 5 is equal to 33. I take the common factor here, and then 3 to the power of x, 6 plus 5 is equal to 33, and 3 to the power of x times 11 is equal to 33, and 3 to the power of x is equal to 3. I divide by 11 on both sides. Therefore, I have the same basis. Therefore, I can equate the exponents. I get x is equal to 1. So understand the difference and identify whether it's a quadratic or simply an exponential equation. And finally, in question number 1, we will come across simultaneous equation. Simultaneous equation implies that there are more than one variable. So generally, it is 2 variables, x and y. So we'll have 2 unknowns, and therefore we may have 2 equations, and we have to solve these 2 equations. So there are several methods, and one method is to make one of the variables subject of the formula and then solve for the other one. For example, y plus 3x is equal to 2, and in the second equation, y squared minus 9x squared is equal to 16. What I have to do, I have to make one of them as subject of the formula. So the key is here to reduce our workload as we do. So try to make one of the variables as a subject of the formula that avoids fractions. I can also make x subject of the formula, but if I make x a subject of the formula, it will be subject to rational numbers, right? Rational expressions, and we want to avoid fractions, and we don't want to make any mistakes. or we, in other terms, we are more comfortable without fractions. Therefore, try to have those equations such that we don't have fractions. Sometimes it may not be possible, wherever possible. So from 1, I make y the subject of the formula. I'm trying to avoid x making the subject of the formula. What I'll do now, I got y is equal to. Right, now I started from 1, therefore I got an equation here. I will not go back to 1, I must go back to second equation, this is number 2. If I start from equation number 2, then I substitute in this equation number 1 to eliminate the other variable. So our purpose is to eliminate the other variable. In other words, we want a equation only in one variable. So what I do here is 2 minus 3x the whole square. I'm putting in 2. I'm putting this in 2. So x 2 whole square minus 9x squared minus 16 is equal to 0. I believe I am in the right track. Now I can simplify it, and then what I get here is 9x squared. I get 9x squared minus 12x plus 4 minus 9x squared minus 16 is equal to 0. Yeah, interesting. 9 negative x square cancels, so it is negative 12x. Otherwise it might reduce to a quadratic one, but this is now reduced to a linear one in x. So 12x is minus 12 is equal to 0. Therefore I can solve it and I get x is equal to negative 1. Yeah, so I am lucky I got only one equation, one solution I mean. Now what I'll do, now I'll put this in equation number 3. I'll put equation number 3. Therefore y is equal to 2 times 3 times negative 1. That will give me 2 plus 3, which is equal to 5. So I got the answers as, so my final answer is xy. You can write in coordinate form, or you can write x is equal to or y is equal to. We apply this property of simultaneous equation in eliminating one of the variables, in functions also, in finding the point of intersection of two graphs. We will also use them in analytical geometry. So in finding the point of intersection of two graphs, we will have two equations of two graphs, and then we solve them, right, making one of the subject of the formula, and solve for x and y. So that is why we are writing them in this coordinate form, the simultaneous equation. So now let me try another question on simultaneous equation that connects the exponents as well. The question now here is solve for x and y simultaneously. 4 to the power of x plus y is equal to 2 to the power of y plus 4, and 2x square minus 3xy plus 4 is equal to 0. Let's take these two equations now. 4 to the power of x plus y is equal to 2 to the power of y plus 4 is equal. As you can see, x and y are in exponents. If I take this first equation, this makes the first equation. What I have to find? I will have to find the equation in x and y. So I'll apply the laws of exponents here. 2 to the power of 2. I try to make equal bases on both the left hand side and the right hand side. So I got this now, 2 to the power of 2x plus 2y is equal to 2 to the power of y plus 4. As you can see, my bases are now same. Therefore I can equate the powers. So for equal bases I can equate the powers, or for equal powers I can equate the bases. So for equal bases I have equal powers, therefore 2x plus 2y is equal to y plus 4. I get this equation now. I can make one of them as a subject of the formula, and that is I can make y I prefer to make y the subject of the formula. So I simplify it and I get y is equal to what I get here, y is equal to minus 2x plus 4. y is equal to minus 2x. So I put as equation number 2. And this is my equation number 3. What is equation number 3 here? 2x squared minus 3xy plus 4 is my equation number 3. And I put y, right? And I put equation number 2 in this equation number 3. Right? That means I replace y with negative 2x plus 4. Therefore, 2 becomes, so for 3 now will become what? 2x squared minus 3x into, I put instead of y, I write now minus 2x plus 4. And then plus 4 is equal to 0. I can simplify, and 2x squared plus 6x squared, and then negative 12x plus 4 is equal to 0. I can simplify further, and I get 8x squared minus 12x plus 4 is equal to 0. I can divide by 2, I can divide by 4 in fact. That is 2x squared minus 3x plus 1 is equal to 0. And I get 2x minus 1 times, I am factorizing. Now, once you obtain the quadratic, I can use the quadratic formula also to solve for x. But I am using factorization. So 2 factors of 2, 2 and 1, factors of 1, 1 and 1. I just have to use the combination now. So I think I am right. So I can expand and see 2x squared. And it's negative 2x, negative 3x. So I think I am covered. Now I can solve for x. X is equal to half or x is equal to 1. So I got the x values, and now what I'll do, I'll put them in. I'll put x in 2. I'll put x is equal to half in 2. And I solve for y. And what I get here, y is equal to 3. And I'll also put here x is equal to 1 in 2. And I get a y is equal to, how much will I get? Y is equal to 2. So I get these values. Now what is my solution here? So my solution set will be, when x is equal to half, my y is equal to 3. And when x is equal to 1, y is equal to 2. So this is the solution for this particular question. So there could be questions that involves, as we see here, involves laws of exponents as well and simultaneous equation. So we may find such integrated questions. The last topic that I will discuss on algebra in question number 1 is inequalities. I will also discuss inequalities when we discuss functions. So the best way to solve an inequality is to see the expression or the inequality as a graph. Any inequality. That's the best way to solve it. For example, let's take this question, 2x squared minus 7x minus 15 greater than or equal to 0. The question is solved for x. Let's solve this inequality, 2x squared minus 7x minus 15 is equal to 0. So if you look at the expression alone, you can very well see that this is a quadratic. So the first step would be to have the standard form of the function that is given. And then what we'll do now? We'll now first solve this this quadratic equation, treat as equation. So what I'll do now, 2x squared minus 7x minus 15 is equal to 0, which I call them as critical values. What I'm going to do now, I'm going to find the critical values. I can use my quadratic formula, I can use my factorization, complete whichever I am comfortable with. I choose to have factorization. What I'll do now, factors of 2 is definitely 2 and 1. Now I look for factors of 15. 1 and 5, 15, that will not give me. I look for 3 and 5. So 3 and 5 might be able to guess. 2, 5 is 10, and then, yeah, that will give me 10 minus 3. So what I'll do, 2x plus 3, x minus 5. So if I take this negative 10x, so if this is negative 10x and this is positive 3x, that will give me difference of negative 7, yes, is equal to 0. And I can find that 2x, x is equal to negative 3 over 2, x is equal to 5. So I can write critical values here. I can straight away write critical values are x is equal to negative 3 over 2 or x is equal to 5. I get these critical values, right? I got this critical value. So simply write the critical values. Now I have to see whether now I have to form the inequality form here. So I see this is a quadratic, and the quadratic shape of the quadratic is a parabola, and this is definitely a positive parabola. It's definitely a positive parabola. So I will draw a parabola here, and this is my parabola shape here. This is my parabola shape. And now I write down these critical values. What are my critical values? My critical values, I got it as negative 3 over 2 and positive 5. This is a number line. This is my x-axis. This is my x-axis. So critical value is nothing but your x-intercepts if you look at the graph, or the roots of the quadratic equation. Now I got this value. Now the question is greater. Now I look at the inequality. Inequality says this is greater than. This is what we are looking now. It is greater than. Okay. I'll change the color of the highlighting. So it's greater than. So now what we want now, we have this greater than. So that means this is my greater than. We can take the highlighter. So this is my greater than values. This is greater than above the x values. This is my greater than x. Greater than 0. Right? This is greater than. So the function is above x-axis. As we look for above x-axis when it's greater than 0. Now I want x values. So what are the corresponding x values that we are looking for? That is what we are going to let's see that. So what are the x values here? So these are my x values that is greater than 0. Right? These are my x values that are greater than 0. So if I look at this, the left hand side of negative 3 over 2. This is on the right hand side of 5. So how do I write on an there's actually number line notation. That is, if this is my negative 3 over 2 and this is my 5. So this is my left hand side. There's a left hand side of negative 3 over 2, and this is my right hand side of 5. Either you must put your x. Either you can leave your answer in this format, and you can conclude, or you can conclude algebraically x is less than or equal to negative 3 over 2, or x is greater than or equal to 5. I put equal to because it's a part of the equality. So that is my answer for this particular inequality. And the best way to solve inequality is to see as a graph. I will solve one more inequality here that will give you a better idea on how we solve a quadratic or solve an inequality, not necessarily quadratic. Let's look at this next question here. And solve for x 2 to the power of x times 4 minus x less than or equal to 0. So again, there is an exponent here. So if I look at these two graphs now, if I look at these two, you can see this is 2 to the power of x, which is your exponential graph. This, you can look at this now here. This is the another one here. Second one is to see this as a quadratic. Therefore, it involves two graphs. One is exponential and the other one is quadratic. So how we are going to solve this now? To see this separately. And then 2 to the power of x, the one is 2 to the power of x. You know this is always greater than 0. The laws of exponents, right? So for any positive base, right? For any positive base, right, that is b to the power of x is always positive, remember this one now. So 2 to the power of x is an exponential graph, so this is always positive, right? So now I have two again. I have this factor law here. A times b less than or equal to 0. It implies, right, is a very important understanding that we must have here. A times b less than or equal to 0. A times b is less than or equal to 0 implies that either a must be less than 0, right, or b must be less than 0 to have two numbers. So when I multiply two numbers, either one of the number has to be positive and the second number has to be negative, or second number is negative, the first number is positive. Therefore a less than 0, they cannot occur together, hence I use the word or, right? That means they cannot occur together. Not both of them cannot be negative at the same time. So when both of them are negative, the same day becomes positive because they are multiplying. Alright, so we apply the laws of arithmetic also here. Or next thing is a times b greater than or equal to 0 implies, and this is very interesting now. A times b greater than or equal to implies that either both of them are negative, and so I'm using this word and here, right? Both of them are negative. Why write positive? Both of them must be negative or both of them must be positive, so that the product is positive, right? So there are two options here. Either both of them are negative or both of them are positive. Hence I use the word and here. Right? While in the case of the less than inequality, only one of them can be negative, not both can be negative. While in the case of positive, both of them greater than or equal to 0, both of them has to be the same, either negative or positive. So this is the simple thing that we apply when there is a mixed functions in the inequality. So 2 to the power of x times 4 minus x less than or equal to 0. So as I already said here, 2 to the power of x is always positive because any positive base b to the power of x is greater than or equal to 0. That means my first function is always positive. So look at the second function. So my second function is x 4 minus x. So I look for which it is negative. For what values of it is negative. That's what we are looking into. So I have these critical values here. I am writing these critical values. X is equal to 0 or x is equal to 4. So I got these two critical values. So I can now write critical values. So what are my critical values? X is equal to 0, x is equal to 4. I am now drawing the graph. If you want to draw 2 to the power of x, yes, you're always welcome to draw 2 to the power of x. And if you know it, yes, you know it is 2 to the power of x. Something like this. Now I am going to draw the parabola graph. This is not parabola graph, as you can now see. This is negative x, and I can draw the parabola graph. So this is as you can see, it's a negative x, right? So x into negative x will give me a negative x squared if I expand them. So now this is going to be a negative parabola graph, and I got this my critical values as 0 and 4. So this is my 0 and this is my 4, my x-intercepts. So this is going to be my graph. Now the question is less than or equal to 0. And you can clearly see from the graph that x less than 0, there is only parabola graph is less than 0. And this is always positive, as you can see that. The exponential graph is always positive. Now I want these x values of, that is negative x values. So what are those negative x values here? As you can see, x values were such that the parabola is negative. As you can see, now I have highlighted it and I want these negative values of x. So now I can draw another number line. Can I remove these earlier ones so that becomes easy for me to, now I'm going to draw a number line here that will say this is my x-axis, and I have got this 0 and this is my 4, and as you can see on the left hand side of 0 or the right hand side of 4, and is equal to, therefore they are inclusive. This is my number line answer. On the number line I can also write my answer algebraically, inequality form, x less than or equal to 0 or x greater than or equal to 4. So this is my solution for the inequality. So here there were two graphs here. One is exponential, the other one is quadratic. The question can also come here now. I am trying to remove all those which we don't want. The question can also may come that involves, we discussed about a times b less than or equal to 0 or a times b greater or equal to 0. The question can also come a over b less than or equal to 0 or a over b greater than or equal to 0. So here the interesting part here is I have still maintained that it implies that either a is less than or equal to 0 or b less than 0. No, b less than 0 cannot have equal to. Remember, I cannot have equal to here because b cannot be equal to 0. B cannot be equal to. This is very clear understanding you must have there. So when it comes to inequality also, we must avoid that answer. So in fact there's an asymptote. Right? If we observe very carefully, look for this graph a times b or a over b. Here also in a over b also greater than 0, I cannot have b equal to 0. That means I must look for a greater than or equal to 0 and b greater than 0. B cannot be equal to 0. Or a less than or equal to 0 and b less than 0. So we must have this very strong understanding also when it comes to solving the inequality. Now what all have we discussed so far? We have discussed so far? We have discussed on quadratic equations, and we know different methods of solving a quadratic equation. We discussed about the nature of roots, and that is coming inside the set of the quadratic formula, right? So then we discuss about the exponents and sets. We also discussed on simultaneous equation. Then we discussed on inequalities. This is what we have discussed so far. So there could be integrated questions on question number 1. So keep trying on questions on question number 1 where you can score maximum in paper 1.